Hello everyone, it's my great honor to share my results. Now I will introduce my paper. It is the singular separation by complex neural network. First, I will introduce my university, Harbin Engineering University. Harbin Engineering University was established in 1923, which defined as a national key institute. In 1996, HU was listed as one of the key universities being enhanced by the first batch of the 2011 project. Now, HU is a highly developed research university and has several world-class academic disciplines such as the shipping industry and ocean exploration. As a national 3A level senior area, the HU campus has a picturesque landscape in 4 seasons, such as spring apple blossom, summer lake hiking, autumn vapor lake, and winter snow carrier. It is a very comfort to learn and live in HU. Next, I will introduce the Smart Radio Technology Research Center. SRTRC is set up by Professor Zhang and Professor Ning in 1950. Now the fracture team has 3 professors, 3 associate professors, and 1 lecturer. There are more than 10 PhD students and 15 master students. The research interests are focused on AI and communication, hardware and software development, software-defined and cognitive video, deep learning, and machine learning over wireless communication. Next, I will introduce fracture advisor. Dr. Ning is a full professor in the College of Information and Communication Engineering, Harbin Engineering University, China. His current research interests include deep learning and data analysis over wireless network, signal processing and analysis, cognitive video and software-defined radio, artificial intelligence, and pattern recognition. He had published more than 115 international peer-reviewed journals and conference papers, such as this. Next, Haoran Zhang, the speaker. He received the BS degree from HEU in 2019. He is pursuing a master position with the College of Information and Communication Engineering. His current research interests includes signal processing and analysis, cognitive video, and software-defined video. I will introduce the paper through the 4 parts. Part 1, Introduction. As an important air surveillance technology, automatic dependent surveillance broadcast has the capacity of tracking aircraft in civil aviation. The aircraft sends its over altitude, speed, latitude, and other important information to outside through the fixed data link. Other aircraft decode and obtain the information by receiving this data, so as to realize global surveillance. The current ADSB system mainly relies on the ground-based station to monitor the airspace, but it still has the questions. However, the ADSB system is faced with a serious collision and overlap problems, which has a serious impact on the signal decoding, leading to the wrong decoding or even loss of the important information. Therefore, a separation method of ADSB overlap signals based on complex neural network is proposed, taking the true signal overlap as the research object. The simulation data is set to generate. After the Hilbert transform of the overlap ADSB signal, it is input into the complex neural network. And finally, the predicted waveform of the source signal is output to realize ADSB signal separation. And the part 2, the methodology. We first introduce The signal structure briefly. We study ATCP signal in 1019 ES format, and the working frequency is 1019 MHz. A long-level signal consists of two parts: a premier with a less of 8 microsecond and a data block with less of 111. The premier part contains 4 parts with less of 0.5 and at the zeros, 1 and 3.5 and 4.5 respectively. The modulation mode of the ADCP signal is ppm modulation. The figure 1 shows the ADCP signal structure. Next, we introduce the complex nature network. The figure 2 shows the scheme diagram of the complex convolution operation, where MI and MR represent the imaginary part and the real part characteristic graphs, respectively. Ki and Kr represent the imaginary canal and the real canal, respectively. The figure 2 shows the complex convolution operation. We study the situation of two ADCP signal overlap because this collision model accounts for the majority of cases. And then the evaluation index considers a bit error rate and the similarity coefficient commonly used in traditional blind source separation. The definition of the similarity coefficient is as follows. Where the separation signal Y approaches the source signal X, the similarity coefficient approaches 1. And then we introduce the simulation part. Experiments on separation effects of the overlap ADCP signals. To randomly generate ADCP signals are selected, as shown in the figure 3, the source signals and the overlap signals. The power difference of the two signals is 3 dB. The time delay is 15 microseconds, and the signal noise ratio is 20 dB. The figure 4 shows the input signals of the neural network. And the figure 5 shows the output signals of the neural network. Obviously, the neural network separates the two signals, respectively. The figure 6 shows the real part of the output signals of the neural network. That is to say, we must use the real part of the output signals. When the power difference between two source signals is 3 dB and the time delay is 11, the curve of the bit error rates is different algorithm series SNR and the time consumption of different algorithms are shown as follows. The figure 7 shows the curve of the bit errors with SNR for different algorithms, just like the fast ICA and the PA. The complex neural networks represent the more efficient results. The figure 8 shows the separation time of different separation algorithms. Obviously, the complex neural network has a better performance. Next, when the two source ADCP signals have different power difference, the curve of bit error rate changing with SNR and the similarity coefficient of the separator waveform and different conditions are shown as follows. The figure 9 curve shows the curve of bit error rate with SNR under different source signal power difference. The figure 10 shows the similarity coefficient of separate waveform under different conditions. And the last part, the conclusion. The complex neural network separation algorithm is better than traditional fast SA algorithm and PA algorithm. When the power difference between the two ADCP source signals is 3 dB and SNR is 5 dB. The BER is more than 19%. The separation speed of the complex network reaches the millisecond level, which is significantly less than other two algorithms. With the increase of the power difference between the source signals, the bit error rate is also gradually decreasing. With the improvement of SNR, the bit error rate of the same source signal power difference is also gradually reduced. With the increase of power difference between source signals and SNR, the similarity coefficient gradually improves. Simulation results demonstrate that ACP signal separation algorithm based on complex neural network has better performance index, and the bit error rate is lower than traditional algorithm. The time consumption reaches millisecond level, which can deal with large-scale signal overlap situation. That's all. Thanks for listening.